Welcome to the session on storage management. In this session, we'll be discussing how secondary storage is managed by the operating system. File system is the most visible aspect of operating system for information storage. Let's start with basic file concepts. We know that computers can store information on various storage media such as magnetic disk, tapes, compact disks, etc. The physical storage is converted into a logical storage unit by the operating system, and the logical storage unit is said to be a file. Files are mapped by the operating system, and it is the most visible aspect of any operating system. It's a collection of related information that is stored on secondary storage. It's a collection of similar records with a common name, and these records are collections of related fields that can be treated as a unit by some application program. Information stored in files must be persistent. That is, the information stored on files may not be affected by power failures and system reboots. Files may be of free form or it can be formatted rigidly. Text files are of free forms, and many different types of informations can be stored in file, like the source programs, object programs, executable programs, numeric data, then different graphic images, sound recordings, that's multimedia files, and so on. That is, files represent both programs as well as data. And we are going to deal with file system, which is the part of the operating system dealing with the files. And for learning files, we need to know something about the directory structure where the files are contained. So we will be going across that topic also. For the files, there has different attributes. The certain attributes which vary from one operating system to another. The attributes vary from one operating system to another. The attributes are name, identifier, type, location, size, protection, time, date, and user identification. What is file name? Everyone knows what is a file name. Every file is having a name by which it is referred. That's known as the file name. Then identifier is a unique number that identifies the file within the file system. And type is the information needed for those systems that support different types of files. And location is a pointer to a device and to the location of the file on that device. Size, we all know that we represent the, had seen the file size in KBs, MBs, GBs and all. It's the size of the file in bytes or words or blocks. Then protection is the access control information that determines who can read, write and execute a file, that is permissions on the files. Then time, date and user identification are giving the information about time of creation of the file, last modified time and the last usage time. So all these are file attributes. Now we will discuss about the operations on file. Normally, the operating system provides system calls for file operations. The different file operations are creating a file, writing a file, reading, repositioning within a file or a file seek, deleting a file, truncating a file, and in addition to this basic operations, we have other additional operations also. So let's discuss the file operations one by one. Creating a file. We all know that this create is for creating a file. Two steps are necessary here. First, space must be found for the file in the file system, and then an entry must be made in the directory for the new file. So the creating step will, once the creating step will be is over, then we can write into the file. To write into a file, we make a system call specifying both the name of the file and the information to be written to the file. Name locates the directory where the file is present. And then reading a file. Once we have some content in the file, we can read. We use a system call that specifies the name of the file and from where the read is to take place. The next command is next operation is repositioning within a file. This is also known as a file seek. The directory is searched for appropriate entry and the current file portion is set to a given value. Then the other two operations are deleting and truncating. So while coming through DBMS, you must have come across this delete and truncate command in detail. Delete is a DDL command and truncate is a DML command. Both of them are doing far or less the same operations, but in delete, record by record searching delete is done. We release all file space so that it can be reused by other files, but record by record deleting is done. When we delete from a table, one by one row is deleted. Then truncating a file means in truncation, the attributes are kept. We erase the contents of the file, but we keep the attributes. And normally in our database systems, truncate is commonly used as it is processing fast. And this truncating a file function allows all attributes to remain unchanged except the file length, which is reset to 0. Then other common operations include appending a file, that is new information to the end of an existing file. Then renaming an existing file. All these are additional operations that can be done on a file. Then next we can have a look into the different types of files. We have executable files such as .exe, .com, .bin, etc. Then object files are there which are represented by .obj. They are commonly compiled machine language or not linked. Their functionalities are like that. Then for different programs, source codes are represented with .c, .java, .pass, etc. Then we have batch files with the extension of .bat, the commands to the command interpreter. Then text files are there which are with the extension .txt. Then .doc files are there. Word processor files with .doc, .wp, etc. Then library files with extensions .lib. Then dynamic link libraries .dll, etc. Then print or only view files such as PDF files .pdf, .jpj, etc. Then archived files such as .zip, .tar, etc. And then multimedia files like .mp4, .mpeg, etc. That is audio, video files we can have with different extensions, multimedia files. Now we will have a look into the file structure. The files can be structured in different ways. OS does not care about the content of a file. It only sees the bytes in the structure and does not care about the content of the file. Both Unix and Windows use this approach. In the record sequence structure, the file is a sequence sequence of fixed length records. In the tree organization, the file consists of a tree of records of varying length and each record consists of the key field. The tree is stored in the key field to allow first searching for a particular key. File stores information and this information must be accessed and read into computer memory. Let's have a look into the file access methods. There are mainly two access mechanisms, sequential access and direct access. Sequential access is the simplest of all mechanisms. In sequential access, information in the file is processed in order, one record after the other. It cannot skip and read arbitrarily from any location. For example, a file consisting of 100 records and the current position of read or write head is at the 45th record. Suppose we want to read till the 75th record from 45, 46, 47 from any arbitrary location. This sequential access. Next is the direct access mechanism. It's also known as the relative access mechanism. Here, the file is made up of fixed length logical records that allow programs to read and write records rapidly in no particular order. That is, records can be read and written randomly without any order. This is based on disk model of a file because disk allow random access to any file block. Direct access files allow arbitrary blocks to be read or written. File is viewed as a numbered sequence of blocks or records. We can have a typical example of direct access with a CD consisting of 10 songs. At present, we are listening to the song number 3. Suppose we want to listen to song number 7. We can directly move to song number 7 without any restrictions. This method is used in many applications such as database systems. Next, we can have another access mechanism which is an indexed sequential mechanism. We know that the main disadvantage of the sequential file is it takes more time to access a record. We can overcome this by involving an index for the file, which is known as indexed sequential mechanism. Here, records are organized in sequence based on a key field. We can keep the index in memory for fast determination of location of data to be operated on. If we have larger files, then we can have index of index. IBM indexed sequential access method (SAM) is a typical example of this. File kept sorted on a defined key and all these are done by the operating system. Each index consists of a pointer to its relative file. We can have an index file having a pointer to its original relative file. Generally, indexed files are used in many applications such as airline reservation systems, payroll systems, etc. Thank you.